Well, hello again. We have again some audio things to do. This active subwoofer power amplifier thingy, and it is blowing that main input fuse. So there is something horribly wrong. Oh, there is a model number. If you are interested of that. What are those? Some kind of inspection stickers. But let's try to a little bit dig out what is wrong. First, let's try to measure the ohms. Maybe the beep will do it. So there should be that fuse. And no! It is not blown. Interesting. Perhaps it is that internal fuse. Then what is blowing? Because the customer said that the fuse is blowing, and he also told that he has already changed the fuse. So I have reason to believe that there might be faulty fuse, but it's not. Interesting. So the fuses are not blown at the moment, but unit is still not working condition. Maybe it is not even broken. Why it is not giving up? Now we are talking. This area looks weird, but it might be for the conch what is put on the caps. let's try to take the wires off. What we really maybe had to do before we even start to tear this down is probably that we should test the unit, but now I am only kinda relaying the info what I have been given, that the amp is faulty. And now we are trying to find the fault. Let's take the board out. And then absolute first what we are going to inspect is that diode rectifier, because it is not cooled one at this unit, it is just hanging there. So it can be really easily to get overheated. That off and that off. Usually if they blow, they will kinda burn out. And I see no burning marks. And they are all flapping freely, so I'm hoping that the amplifier transistors should be okay. Is it loose? It is. Let's try to disconnect the board. Whee! Like that. Housing is clean. No any burning marks. But what on earth is going on here? Again, it might just look bad. I think it's only is looking bad. But let's try to measure this thing first. This is the thing what I am now curious to see if it is working or not. Let's go to diode mode. these are the mains input leads, and they should go to diode rectifier, and they go. So we have connection here to there. So we are putting AC power here, but there should not be voltage between these two, because the power should go there. There is one diode, and there is another one. It's good. And the another side, diode is good. Diode is good. But what is that? What is causing that 1 volt between those? It's interesting. I can just imagine 213 volts and 1 volt voltage drop. It will burn the fuse. Could it be here? No. It is not. There is that diode rectifier. 1 volt. So odd. But the resistance is still pretty high. What I am not going to understand now. Oh, let's check the capacitors. Probably I should do this for beginning, but I didn't put the AC power to unit, so I thought that there is no power in the caps, and there is no power in the caps. All right. Then we can check the datasheet of those. Those are the same components. I assume they are parallel. Sharing the load. They are. And seems that they are totally shorted out. I don't know yet, is it the positive side or negative side of the amp, but probably they should not be totally shorted out. Let's see what is behind number 2. Really? That's odd. If I remember right, the LM370 is a regulator, and that is same part, the regulator, and that is probably the diode. No, it is not. I have to check the datasheets for the components, what they are doing. And then I am going to be back here. But for now, wait a minute. What is here? What? I didn't expect the double-sided load on the PC port. I have to inspect what are those. I'm trying to focus the camera to see the model numbers. There. But yeah, now we need datasheets to be kind of more sure what is happening here. I did not watch the datasheets yet, but I took off the another PC port here and just measured around. Then I decided to power the power supply port to see what happens. And here is my amp meter, the multimeter in the ampere modes, and here I have adjustable AC power supply, and immediately when I start turning the voltage I have a fucking a lot of amperes. So it means that my first impression of that thing, that why there is that 1 volt voltage drop between straight in the AC input. It is correct, and it is now making the fun of us. But there is not much components what can cause that kind of problem, and I am guessing that it is the blue one what is now giving the headache. So I will remove the test gear, and then we can continue together to see is that thingy gone bad. Yeah, here we are. Ooh, almost here. And I am assuming that the blue thing, it is called, I think, varistor, and it is for over voltage protection device. The working principle is that if there is over voltage, it will create a short circuit, and it will then blow the fuse and protect the device, that there is nothing else left to be burned out because the over voltage. And that blue thingy here, that one, is located there. So there. Now I am trying to check if it is, yeah, connected straight between the AC input side. Oh, but one thing what we probably should check is that our main output, because we can have a short circuit straight after the diode rectifier. That is the positive output from the rectifier, and that is negative output. Yeah. So here is our short circuit, and not here. It is showing that odd 1 volt what I measured beginning, but it is still in resistance mode, high kilo ohms, so it should not give the headache to us. But here, it is short circuit. Dun, 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 just before the diode rectifier. But what is causing that short circuit? I'm pretty sure that it is not a cap. Yeah, it is not a cap. So it should be between those pins. Yeah, and it is. Could it be those two what I already measured? That they are fully sorted out. Or not fully, but almost. And I haven't even checked the datasheet. One moment, please. Here is the datasheet for those, and it is N-channel, IGBT, ultra-fast, MOSFET, and it has to drive the switch mode power supply here. And middle leg should be a gate, and there should our power come in and goes through here if the connection is made. Collector to emitter. And it is showing the 0 volt. So 0 volt between here and here. And same result on another way. And also into gate. I'm betting that those are gone. Maybe I should desolder one of them. And measure it without the PC board. And I'm now a little bit lazy because I'm going to bed. I'm tired. I will just use my soldering iron to melt the solder. And my finger. my iron is still heating up. It is not melting the solder. It is tight. It was really tight. And now moment of truth. Da, 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 da. Is it totally shorted or not? And it is. Yeah. It is totally broken. Times 2. And I'm betting that if I took both of them off, then the amplifier is not anymore generating the short circuit and getting the amperes. Of course, it is not generating the power what we need to drive the amplifier. But at least we see if the short circuit is removed. Little bit cleaning. main goal at now is only to separate the pads, that they are not touching each other. And I think that main goal is now completed. And now if we do the same measurements, so there is that our main. Oh, it's gone. Our mains input odd 1 volt and voltage drop is gone. It's no more here. It's good, and we have now short circuit anymore here. So the diode rectifier is generating the positive DC power, and it is going straight here, and diode rectifier negative terminal is connected here. So it will generate between those two capacitors the high DC voltage, and then we can use that power to generate all kind of voltage what we are going to need in the amplifier. But now we need those. I don't have these. I have to go tomorrow to shop to get them, or at least similar ones, to get the amplifier back in business. Yeah, thank you for watching this episode, and let's see, will it be fix or no fix. Thank you for watching and have a nice day. Hi, here again, and these are the old IGBT modules what are bad, and here is the new ones. They should be kind of similar compared to the old ones, but package is much beefier. But it's all right. Let's do a quick test. If I first test that old one, short, short, and the new one, no short. So at least I was right. They are completely dead, and new ones are not. Yeah. Let's try then. Let's try. And the PC board was kind of funny because there is already a mounting holes for the bigger transistors. So it is hybrid PC board. It can take a big package or the small. But now we have to take the solder off. I will try to do it somehow that way that we can see what happened. No. No. It's too big PC board. It absorbs heat a lot. I have to try to take the solder off a little bit older fashioned way. I have one trick in my sleeve. Double gun. Yes. And yes. Fits like a glove. But now on here is one thing what we have to figure out first. I don't know. It is not going to fit yet. I don't know how the tightening clamps will work with that bigger transistor package. We need to check the right height for the transistors. Let's try to figure out it. If the PC board is here, and you can't see nothing, and the transistors are there, how it is going to work with that? Yeah, I would say there is plenty of room. You can almost see the mounting hole. So a little bit lower, but not much. Not much. Let's say a little bit lower. Let's put them there and there. And yeah, I didn't tell you, but I checked already that transistor mounting. It's annoying when my light is coming upward, but these two pads are connected together, so are this and this, so it is designed to take double package, either the big or the small one. Now we will cut the excess. Actually, let's not connect that yet. I have easier access to mains input when I am testing the unit. Soon it will be time to put your pets. Will it work or not work? Or is there something else? What is causing the problem here? Yeah, but we can now try it. Or at least I think so. It is not ideal setup for the powering the unit, but it is at the moment best what I can give. And for compression I will put my multimeter here. Because I want to see how many amps the thing is taking. Let's take that off. Alright. This part is a little bit dangerous. Don't try this home, because when I am starting to apply the voltage, the system, we have a live voltage here and here, so it is not smart to touch any of things when I am cranking the voltage up. It seems to be much better. We have now 115 volts, 200 volts, and it is taking only 100 milliamperes. Alright, I will crank the voltage down and unplug the thing. Because we want to see another side of the unit, if there is a light. When I power it. Oh. Taking power but no light. That's interesting. I assumed that there should be a light. There is absolutely no light. Yeah. It might need now I'm just seeking that there is no any power switch anywhere. But I can't see. It should turn on. but it is not turning on. Alright, one moment please. I have to take the power supply port out of the casing that I can do more measurements. Yeah, sorry for a mess. It took me a while to figure out what is wrong now. And what I found was that here and here is our main capacitors what are holding the rectified AC power, so we can call it the DC bank, and this is DC bank minus, and in the positive side of the DC bank we had a couple of resistors and some filtering thing, and then the power went here, and there was that tiny switcher, and it was shorted to ground. I measured the resistance between here and here, what should be the positive VCC for the switcher, and it showed like a 1 ohm or something. So our rectifier circuit is good and the power was delivered through the switcher, but inside the switcher should be 15 volts Zener diode clamp, so it is some upper limit how much voltage you can apply for the pin, but it will clamp it down to 15 volts, and then the driver IC will drive the IGBTs and generate the power to us. And it was really hard to see what the part was, but I managed to read it and found the datasheet for the component. And here is the circuit, and the circuit matched to the board, and now I have to order a new switcher. High side floating supply voltage, maximum voltage 600 volts. Yeah, but now the repair is going to be on hold stage again. It's annoying, and I have to order that switcher IC to get the repair back on the right tracks. So it is all for now, and it is of course possible that the IC driver has gone bad, what has caused the blown of these two IGBTs. But we already changed new IGBTs, but the switcher is dead. so yeah, I will come back after I receive my parts, what I need for this job. Thank you for watching again, and have a nice day. Thank you for watching and have a nice day.